Okay, this video has to do with taking the derivative of natural-based logarithm functions. So we have y equals natural log x. And the first thing we're going to do is rewrite that as an exponential. The point of rewriting it in an exponential is because we just practiced taking the derivatives of a natural-based exponential function. So if I have y equals natural log x, that means I have log base e. So I rewrite that using my logarithm definition. E to the y equals x. So if I take the derivative of both sides of the equation, that means I'm going to take the derivative with respect to x of e to the y. So that's an implicit function. I'm going to use implicit differentiation. And on the right side, I'm going to take the derivative of x with respect to x. On the left-hand side, the derivative of e to the y is e to the y times dy dx. And on the right-hand side, the derivative of x is 1. So I get the dy dx by itself. That gives me 1 over e to the y. And originally we said e to the y was equal x. So it looks like I made a mistake there, because it says 1 over e to the y. And 1 over e to the y is x, not natural log x. So we'll use whiteout. There. So derivative of e to the, derivative of natural log x is simply 1 over x. There's your rule. Get the chain rule version on number 2. Okay, so for this first one, put a red dot by it. Y equals natural log of x to the 3rd power. Because it's a logarithm, you can rewrite it using properties of logarithms. So you could rewrite this as natural log, or 3 times natural log x. All right, let's see. So if y equals natural log of x to the 3rd, we could also say that that's equal to 3 times natural log x. The derivative of 3 times natural log x would be equal to 3 times 1 over x, or 3 over x. Now, I don't think that's what I did originally, so let's see what I did originally. So originally I said that the derivative of natural log x cubed is going to be 1 over x cubed. That's where the x cubed came from on the bottom. Times the derivative of x cubed, so using the chain rule. So the derivative of natural log x to the 3rd is 1 over x to the 3rd times the derivative of x to the 3rd. Well, the derivative of x to the 3rd was 3x squared. Now, when that simplifies, we still get the 3 over x, which is what I did on the other program I pulled up. Kind of to show you that whether or not you use properties of logarithms first or not, you can get the same answer. So the first time, again, what I did was I said 3 times natural log x. The derivative of that is 1 over x times 3. But I can also use the chain rule. For the second one, the green dot. The second one, I have the product rule, x squared and natural log x. So if I take the derivative of x squared, I get 2x. So derivative of the first is 2x times the second, natural log x, plus the derivative of the second, natural log x, is 1 over x times the first, x squared, plus the derivative of 5x, so plus 5. Then we just clean that up. For the third one, purposely trying to use the quotient rule. So the derivative of the top is 1 over x times the bottom, x cubed, minus the derivative of the bottom, 3x squared, times the top, natural log x, all over the bottom squared, x to the 6th. Clean that up a little bit. Clean up a little bit more. All right, and this last one, y equals natural log of natural log x, is designed to be a chain rule. So what's the derivative of the natural log of x? So use my highlighter. My outside function is the natural log of something. So my derivative is going to be 1 over something. Then when I take the something, I need to take the derivative of the something. Derivative of the something is 1 over x. And so when I multiply those together, I get it. So it's the derivative of the outer function, which is yellow in the first part, times the derivative of the inside. All right, so when you have something a little bit more complicated, instead of, like on this first one, natural log of the fraction x cubed plus 4 over x, instead of writing 1 over all that times the derivative of all of that, which is the quotient rule, I could just use properties of exponents. So I'd like you to pause and think about how you would use properties of exponents. Sorry, properties of logarithms on this first one. You have natural log of something divided by something. So you can rewrite that as natural log of x cubed plus 4 minus natural log x. And now I can just take the derivative of both parts. So the derivative of the first part is going to be 1 over x cubed plus 4 times the derivative of x cubed plus 4, which is 3x squared. And then minus the derivative of natural log x, 1 over x. Get a common denominator there. Clean it up. I won't always make you do the common denominator. So you'll see that on some answer keys. Again, on the second one, I have natural log square root x plus 1. So I could write it as 1 over square root x plus 1. And then take the derivative of the square root of x plus 1, involve that chain rule. Or it could be easier to rewrite this as natural log of x plus 1 to the 1/2 power. So if I write it as to the 1/2 power, properties of logarithm says I can move that power down in front. So 1/2 natural log x plus 1. Take the derivative of that, I get 1 over 2 times x plus 1, because the x plus 1 goes to the bottom. And then the derivative of x plus 1 is just 1. This example is intended to show you implicit differentiation. So I'm just going to move the blue box down slowly, talk about each line. You can pause it as you go and see if you can work it out on your own. So the derivative of the first part is just 2x, that's easy. The minus 3 natural log y. Derivative of that is going to be negative 3 over y. Right? Derivative of natural log y is 1 over y. And then times the dy dx. And plus y squared, we talked about that, 2y times dy dx. Into your next step. You factor the dy dx out. Brought the 2x over to the right. We divide, clean up that complex fraction, and you're done. And sorry, I keep clicking my mouth. I don't notice that until I go back and listen to the video. Something to work through, I guess. So second derivative, again, just showing that you can take a second derivative. First derivative is just a chain rule at the beginning with the square root. Then a product rule. So for the product, we're taking the derivative of e to the x, which is e to the x times natural log x. So derivative of the first times the second, plus the derivative of the second times the first. the second derivative, just continuing that process. Don't really need to clean it up or get a common denominator there. That's just messy. And that's it. So 2 videos to help you get started. Feel free to YouTube or Google search for more videos. You can look at Khan Academy. If you need something, you can ask me specific questions. Haven't decided if I want to make videos going through specific homework problems or just be available online. So we'll kind of figure this out as we go. Appreciate you guys putting in some time and trying to learn through this different time. As always, if you have questions or concerns or you're feeling anxious, I want you guys to know that you can reach out to me and I'll do what I can to help you out. All right. Thanks, guys.